Hey, physical science class. I'm going to just quickly go over all of the information that's on Thursday's test on Module 9. So just going to kind of do what I often do and summarize what you need to study the most in order to do well on the test. First of all, the vocab section. There's only 5 terms, and it's going to be the normal format, fill in the blank with the term. And so the terms you're going to need to know definitions for are acceleration, vector quantity, scalar quantity, reference point, and free fall. Again, that's acceleration, vector quantity, scalar quantity, reference point, and free fall. Now for the actual questions, understand reference points. There's a couple different questions about reference point, and those on your own questions that deal with, like, say, two people on an escalator, and are they moving relative to each other, and are they moving relative to the security guard watching them? Those are going to be helpful, so make sure you review those. There's also going to be a speed problem where you have to calculate speed, and remember that speed is distance divided by time. There's also one where you have to calculate velocity, which works exactly the same way, except that you have to include direction. And in the problem, they'll give you a direction. You just add that to your answer. They're going to give you 4 different quantities, like, for example, 15 feet, 32 feet per second squared, and I'm just making up those numbers. They're not the exact ones on here. And you're going to have to be able to look at all of these quantities and tell what they are measuring. Like, for example, are they measuring speed? Are they measuring velocity? Are they measuring acceleration? So make sure you understand how to do that. And also, maybe they're just measuring distance. That's another possibility. So be able to tell the difference between all those types of measures. You're going to have to calculate relative velocity for one of the problems. And remember that with relative velocity, if the objects are moving in the same direction, then you subtract their speeds. But if they're moving in opposite directions, then you add their speeds. There are example problems on your own questions that will give you practice with that if you need to review. All right, there's going to be one where it's going to be useful to know exactly what it means for something to change velocity. That if it speeds up, it's accelerating. If it slows down, it's accelerating. And if it changes directions, it's accelerating. If it's not, then its acceleration is 0. So 3 ways that something can accelerate: speed up, slow down, or change direction. You're going to have to calculate acceleration in a couple of different questions, so make sure that you know how to do those types of problems. And remember that the formula for acceleration is final velocity minus initial velocity divided by time. There's going to be some questions about dropping objects in free fall and things of that nature. In fact, there are 3 different questions dealing with dropping objects. You're going to have to explain that video I showed you where there's, on the moon, basically they're dropping like a feather and a hammer at the same time, and they fall to the ground at the same time. Why is it that those 2 objects, even though one is heavy and one is light, actually fall at the same rate in a perfect free fall where there's no air resistance? So understand that. Understand how free fall works and how it works on heavy versus light objects. Why, say, dropping a paper, it doesn't actually experience free fall because of wind resistance. Whereas if you drop a book, wind resistance doesn't have any serious effect on it. Did I say wind resistance? I meant air resistance. Air resistance doesn't have any significant effect on it, and so it basically experiences free fall. And finally, be able to calculate distance using free fall. So in other words, if you drop something and it fell a certain number of seconds, how far did it fall? And so example 9.6 is the one you're going to want to look to for that. That's the one where it has that distance equals 1/2 and then times, acceleration time. Anyway, there's a formula for calculating distance in free fall, which is used in example 9.6. So definitely study that one. Other than that, there will be at least 1 extra credit question, and I hope you all do well. Thanks very much for watching. Take care.